Hey guys, and welcome back to my video series where I'm working through the challenges in my book, The C# Player's Guide. This week we're going through this Uncoded One challenge, which is I think it's the 8th in the series of the core game. There's 18 total challenges in the final battle. 9 of them are the core game. We are getting very close to being done with the core game. We'll soon move on to the expansions. But this is the one we're at now. So we've been working through a whole bunch of stuff in the past 7 challenges getting us to this point. In this one, we're going to add in the final boss, the final big bad guy, which is the Uncoded One, which represents, I don't know, it's like a ethereal, malevolent, I don't know, creature. It's even hard to call it a creature, but this entity, that wants to eliminate all code, all all organization, and anyway. So we're going to introduce this new character. This needs a different attack that deals a certain amount of damage, and a third like battle to the series. And if we played our cards right, this should go very, very fast, because we should have already built a system that allows us to define new character types, which we need to do, new attack types, which we need to do, and new like parties that we fight against, which we should already have. So this should go pretty smoothly. If it doesn't, it means we got something wrong with the design, and that's okay. So we don't always get everything right, but let's start working through this. So first things first here, we already have, let's start with the attack. So there's an unraveling attack. We already have these 2 attacks, punch and bone crunch. We should be able to just kind of follow the pattern here. And we don't, oh, actually we do need this random, we do need a random number generator. So let's put that here. And this should be, what did I say? 0 and 2 damage. So 0, 1, and 2. So up to, but not including 3. So there's our attack. It does make you wonder if there isn't a better way to handle, like we got a random in both of these, and even a lot of this is like what if, like, could we make a base class that's like a uniform random damage? And we could do that. I don't know, like, so we could make an abstract class here, and then could, like, for example, pass in. So we could put this in here, and then we could I don't know, something like we go down this path and then make this derived from uniform random. It's uniform because it's a uniform distribution. Each value has an equal weight, and it's random because there's like multiple choices. And like for this bone crunch, the choices are 0 and 1, and for this one it should be 0, 1, and 2. But there's an equal probability of getting 0 as 1 as 2. So that's why it's uniform. That's why I'm calling it uniform. It's a math term. Alternatively, we could do something like this. We could just, instead of that, we could do public static class. We could just like make a little utility, attack utilities. and put the random here, and then do ditch this and do I don't know, maybe something like should that be an int? Yeah, let's call it int. Public static int between, you know, some int min, int max. And then here just say, you know, basically return random dot next. This is going to get more complicated if we can totally handle that, but anyway, something like this, and then we can ditch this random and this random, and just do attack utilities dot get random damage to attack utilities get random damage 3. So now this like random number generation code is all it's all in one place. But I do think, I mean, we were talking about this, so int min, like the way to do this is, because this will next will always generate a number between 0 and up to, but not including the max value. So if we want to do, what I'd like to do is to be like, what I'd like to be able to do here is say something like 0 to 2. And this is between 0 and 1, and to like do it inclusive. So I've specifically called out inclusive in the variable name so that it's clear what it means. So we can do max inclusive minus min inclusive. Thinking this through fairly fast because I've done this type of stuff before. Plus min, and I'm going to say that, and I'm going to make a mistake on it, but since we want this to be inclusive, so like if we do say I want a number between 3 and 4. I want it to either do 3 or 4 damage. Let's think that through. So min inclusive is 3, max inclusive is 4. This would be 4 minus 3 is 1 plus 1. So this would call random.next with a value of 2, which should give us 0 or 1, and we add to that the 3. So it'll either add 0 to 3, which is 3, or it'll add 4 to 3, which is 4. So I do think that's correct logic. I will say, though, that 10 years ago, 15 years ago, 20 years ago, I might have spent an afternoon messing with this entire, like this code. So I came up with it pretty quickly because I've done this kind of stuff a lot, but if it took you longer to think that through, don't feel bad. So now I want to set this back to what it's supposed to be, which is 0 to 2. And now I've just got this little utility class for attacks. And if we come up with other utilities, we could stick it in there. So rather than injecting inheritance into this, we can get code reuse by just having a little static utility class. And I am generally pretty happy with that. So, all right. So we need another character. Where are our other characters? So this is going to be more like the skeleton than the true programmer because we can just use a hard-coded name. Debating whether to put the in front of that. But this guy's standard attack will be Unraveling. And this was supposed to be what, 15? 15. So that was pretty straightforward. And now the last piece here is adding a third battle that has the Uncoded One. So we can just do Let's let this run. And then we've got a couple other things to talk about. In terms of design, I just had a thought that I think is worth working through. Well, this is going to be a close battle. don't don't know how this is going to work. Punches guaranteed. The other one comes down to randomness, and it'll be 0, 1, or 2. I kind of let's make sure that's unraveling dealt 2 damage, unraveling dealt 0 damage. Okay, I mean those are the limits. That was a close battle. It wouldn't surprise me if we ran it again. You know what though? We got that thing in here that's got the 500. I'm gonna reduce that. I'm gonna speed that up a little bit since we're sitting here waiting for it to run. Now the game's faster. I think this one's gonna work out okay, unless we get a whole lot of 2s here. I tend to 5. So this is actually feels like a fairly balanced game. Like we've ran it twice and each side won once, which is good. Okay, we've checked all the boxes for what we needed to do for this, and I will say that I'm generally fairly happy with the structure of things, but I do want to cover this one little like design question here, and that is, it feels like we are making classes when we're making classes in a situation where we could get away with just new instances of the same class. And by that I mean, it could just be something that we put in this character class. But for example, like maybe we could do something like public class basic character, and we could do, so this should derive from character. And then so like this has name, standard attack, and then it passes like the hit points down. So like one thing we could do here, instead of what we've got, instead of having a skeleton class, is we could just say something like public class, public, I want a constructor here, basic character, and then pass in the name and the standard attack and the hit points, and then this needs to call the base with the hit points, right? But then we need public override string name is that, and then let's go down in here and do name is name, public override attack. Sorry, no, that is right. And standard attack is the standard attack we passed in. And now we have one class that could arguably be used for any right now. This has the flexibility to be used for anything that varies only by name, their attack, and their HP. And so we could, up here, we could say, instead of new skeleton, we could say new basic, what do they call it? Basic character, and we pass in skeleton and new bone crunch, and what's a 5? So there, now we have, and we could do that for everything. And now we've eliminated potentially, if we do that for, because we know we can do that for the skeleton and the uncoded one, And honestly, it probably wouldn't be like this true programmer. Like the only real difference here is that like the name is like set like this. We got this like two upper. Like this is the only part that's like makes the true programmer unique. And we really could just make we could like given that we say we pass in the name here, if all we did is we just put in, a two upper here, we could fold in every single one of these classes into just this basic character class. And in fact, if we're going to do that, we could just have like not have an abstract character class and a basic character class. Like we could just have a single character class that so no different no different character types. Now I will say to be able to just say new skeleton is just say new skeleton is way more convenient than new basic character skeleton bone crunch 5. One of the things is that if we could accidentally make something inconsistent. We could like accidentally make a skeleton that if we fat finger it, we could end up with a skeleton with 50 HP, which we didn't necessarily mean to have. However, there are other things we could apply here. We could do public, like a static factory method, like we did with like Vin Fletcher's arrows, where we've got a set of things that are common, and we could just say public static basic character, and we could say make skeleton. And then this could say return new basic character, skeleton, new bone crunch, and 5. Right? And then we do this for make true programmer. In this case, we would want to pass in the name. And in this case, we do new punch. And I don't remember what this guy, I think it's 25. Make the Uncoded One, new basic character. New Unraveling. This was, I think, 15. And now up here, you can just say, instead of, new basic character skeleton, you can just say basic character dot make skeleton. And actually, you could make this a property if you wanted. Most properties you don't like mentally think of as like creating an object, which is why I did it this way. Another thing you could do if you want to go down this path, and I'm just like, these are like wild, crazy ideas that you could go down. I'm going to not continue down this path. I'm going to undo a bunch of this. But another thing you could do is you could have, instead of this like returning a new one every time, you could do a property like that, and then you could on here you could make a new public could be just public basic character clone, return new basic character name standard attack HP current, well, max. I don't know which one to use. So now you have the skeleton, and now up here you would just say basic character dot skeleton dot clone. You could do something like that. There's a lot of different things you could do here, and there's a lot that I do like about this approach of not having different derived types for everything. At the same time, yeah, keep going back. Hang on, let me finish undoing, and then I'll finish my thought. So yeah, so like I said, I have very often said to myself and to other people that you should not create new types when instances will do fine. Um, So and we're right now this design is going down a path of we're going to have a different class for every different type of creature. And one like it is really convenient to just say new skeleton, new skeleton, new skeleton, new the uncoded one, new true program or whatever it is. Like it's really convenient to be able to just do that. Um, and I kind of like that approach. One important difference, one important limitation of that is that the creatures itself, the characters themselves, like they're locked into like a type is a very strong, um, I don't know, it's a very strong set of like constraints. What if something is a skeleton, it can never become something else. You would have like you must delete it and make a new thing. So I don't necessarily foresee a skeleton being turned into anything else, but at the same time, like you could imagine like I don't know, something where like as something's going on, like it evolves into something else, and it was a skeleton, but it's no longer a skeleton. And the other limitation here is like the way this is set up. All skeletons will have, without equivocation, they will all be named skeleton. They will all have a bone crunch attack, and they will all have 5 HP. There is, as this is set up, there's no way to do it otherwise. Now, we could add some flexibility in here. I mean, we added in flexibility for this class to have a different name, and we could allow skeleton to have, for example, some like you could do something like you could do something like that, and then pass that over to this property, so it can be overridden. Like there are definitely some options here. But some of those other approaches that we were talking about, where like let's suppose you have just a separate, like a skeleton, like prototype, like the thing. It's like in Unity they have things called prefabs, where you have like you define what this game object should look like, and then you can take those and just drag and drop them into the editor, and just now you've got like a thing that's based on that prefab. So something like that, where we like what we were doing with like the clone method, where you have a set of characters that are kind of your stereotypical normal characters that you can just take and just like make a copy of and just start using it, is I think a viable approach as well. So I think anyway, again, this is the type of thing where in terms of design, there's a lot of different people with a lot of different opinions, and the right answer may depend on subtle choices in terms of what you want out of the game, and or out of the game. We're making a game here, that's why I say game, but software in general, and it does take a while to like. It's one thing to like understand like the mechanics of making a class, understand the mechanics of making like an abstract class or an interface. It's another thing entirely to feel like you really have a firm grasp on why should I be deriving from a class here versus should I be doing something like the clone approach that we had a second ago, or should I be doing any of a number of a dozen other possibilities. What makes this choice better for my current situation, and what makes a different choice better? So that's a whole tangent that goes well beyond um, just adding in this uncoded one final battle. By the way, you can make the exact same argument here about all these attacks as well, as that rather than having a separate class for each of these, you could have one basic attack, and I mean honestly, there's room there for both. You could have basic attacks, and then if you need something specific, you just go re-implement I attack separately. So there is room for maybe a little bit of both as well. So anyway, I guess I've gone on too long on that tangent. We're way beyond just adding in this extra thing. But like I said, we're definitely in territory here where there's many ways that you could do it. And it's okay to not feel like you know when to apply any of these different tools. There are rules. We've talked about some of those in this video, but more than that, a lot of it comes down to just sometimes you need to just give it a try and then be like that critical analysis part of, did this work? Or like, what about this made this not work as well? Or what about it made it work really well? And like that critical thinking about why it's working or not working, so that you can understand like what context does this approach work in, and which situations does it fail in, so that you're better informed for the next time it comes up. So a lot of it really does just come from that personal experience, that you've built 1,000 things like this, and so now you have a pretty good grasp on what's going to go well and what won't. But anyway, enough about that. I think we can wrap up this video. So thanks for joining me for this, and I will see you guys next time.